Today I am going to talk about numerical solution of simultaneous ordinary differential equation. So here I am putting one exercise and then I will solve this problem and I will show you how to solve simultaneous ordinary differential equation. Now in this exercise problem, two ODs are given here. So one OD is dcu by dt is equal to minus e to the power minus 10t plus 273 into c, and another is d capital T by dt is equal to 100 into e to the power minus 10t plus 273 into c. Now here c and capital T dependent variable, and small t is independent variable. Now here this first OD, that is the function of, this is function 1, function of small t, c and capital T, and this is also function of, means both OD depend on small t, c and capital T. Now I'll show you how to solve these two OD by using Runge-Kutta fourth order method. Here I am taking step size h is equal to 0.5. Now you know fourth order Runge-Kutta method for single OD. Suppose dy by dx is equal to f of xy, that is single OD, first order obviously. So how do you solve by using fourth order Runge-Kutta method? So first we have to calculate k1. k1 is the slope. So that is nothing but h into function of xn and yn. So x and yn is actually two variable. Yn, n is actually the ith x and y value. So if you take n is equal to 0, so that is x0 and y0. So initial value. Now k2, after getting k1 we can calculate k2. k2 is hf xn plus h by 2 yn plus k1 by 2. H is the step size of the x direction. So here xn plus h by 2. So xn means xn already we know from that condition, and h is the step size, so we will get this, and yn also initially we know at particular initial condition. We know that what is the value of yn, and k1 we will get from here, and then we can calculate that yn plus k1. After getting k2, so we can calculate k3. Similarly after k3, so we can calculate k4. So remember this formula already. If you solve already, I solved the first order OD one problem, so you can check my video, so you will get it. You know how to solve this first order single OD by using RK4 method. So after getting k4 k3, so then take the average, okay, and then we'll get that yn plus 1, means next step y value, that will be yn plus k1 plus 2 k2 plus 2 k3 k4 by 6. So this is the fourth order Runge-Kutta method to solve single order single OD using the same formula. So there is some small change for simultaneous OD. Now here next, so I'll explain the theory behind that RK4 method when we are going to solve two ordinary differential equation by using RK4 method. Okay, so here the two ordinary differential equations are there. So one is dy1 dx is equal to function 1 of x, y1, y2. So x is independent, y1, y2 is dependent. Okay, and in this side dy2 by dx is equal to f2 x, y1, y2. So now both ODs are function of x, y1 and y2. Now we have to solve that both OD simultaneously by using RK4 method. So no, previously I already discussed. So first we have to find out the slope. So now for this OD we have to find out k11. k11 is nothing but h is the step size of the x direction, h into f1 x to the power n, y1 to the power n, y2 to the power n. And similarly for this k11, okay, and here uh, for this, from this ordinary differential equation we have to calculate k12. So that is h into f2 x to the power n, y1 to the power n, y2 to the power n. So after getting k11 and k12, so we can calculate k21 and k22. So k11, that is h into f1 x to the power n, h by 2, y1 n, and k11 we will get from here, and then by 2, and y2n plus k12 by 2. So here, so remember this function 1, so that will be k21, we will use this function, and for k22 we will use function 2. So because of because this side OD we need k22, so k22 is function 2, and similar variables are there, xn plus h by 2, y1 n to the power n plus k1 by 2, y2 n. Similarly we can calculate k31, k32, and then k41 and k42. Now after getting k1, k11, k21, k31 and k41, so we can calculate that y1 n plus 1, so that is y1 to the power n, k11 k plus 2 into 2, k21 plus 2 into k31 plus k41 by 6. Similarly for y2 n1, so that will be, this is 2, this is also 2, this is 2, this is 2, so that's the equation number. So y to the power n plus 1 is equal to y2 n k12 plus 2 k22 plus 2 k32 plus 2 k42 by 6. So we'll get the y2 n plus 1. Means next step, what will be the y1 value and y2 value we'll get. So this is the theory behind solution of two ordinary differential equation by RK4 method. Now I'm going to solve the exercise problem. Now here, let's compute the numerical approximation of the solution using fourth order Runge-Kutta method for t is equal to 1 with step size 0.5. Okay, now here we'll use step size h is equal to 0.5. Now here two ODs are here. So one is dCA by dt and another is dt by d capital T by dt. So both ODs are function of Tn, Cn and capital Tn. And second OD also function of Tn, Cn and Tn. And first OD I am considering as a f1, second OD I am considering as a f2. Okay, now and given data at t is equal to 0, that is 0, c0 is actually 1 and t0 is actually 25, so that is given. Now we have to calculate for first order OD we have to calculate k11, for second order OD we have to calculate k12. So first from first order OD means we are going to calculate k11, so that is equal to h into f1 t0, c0 and t0. So we know t0 value, c0 value and t0 value, capital T0 value. So h is equal to 0.5, and as we are going to calculate k11 for first function, first OD, so that is function 1, so 0, 1, 25. 0 means t0 value is 0, c0 value is 1 and t0 value is 25. Now we have to plug this function. Okay, so this equation, so that is 0.5 is the h, and then in that function minus c to the power minus 10, t plus 273. For t here is 25, 273 into c is here 1. So after doing that we will get that k11 is nothing but minus 0.4835. Now we are going to calculate k12. K12 means k1 and equation 2, so that I will calculate from this OD. So that is h into f2 t0, c0, t0, capital T0. H is 0.5, f2, that t0 is 0, c0 is 1 and t0 is 25. Then we have to plug all this variable value into that second equation, second OD, that is 0.5 is the h, and then 100 multiplied with e to the power minus 10, t plus 273, t is equal to 25, 273 into c is 1. So I will get k12 is 48.35. Now we have finished k11 and k12. Similarly, we have to calculate k21 and k22. So k21, how do you calculate? So that is h into f1 t0 plus h by 2, c0 plus k11 by 2. So k11 we already known, and then t0 plus k12, so that is also known. So h is 0.5, f1, so t0 value we know 0, h value is step size 0.5 by 2, c0 is 1 and then k11 we know, so that is actually, this is actually minus 0.835, then 25 plus 48.35 by 2, so that we know k1 to known value. So after doing all this calculation, so that f1 h 0.5 f1, so that is 0.25, then 1 minus 0.4835 something, so by 2, so then we'll get 0.75825, then 25 plus 48 by 3 by 2, so that will be this. And after getting all this, then we plug that equation 1, plug this equation 1, so that will be minus 0.36754. Similarly, we can get k22, so that is h into f2 t0 plus h by 2 c0 plus k11 by 2 t0 plus k12 by 2. So here we plug everything, 0.5 into f2, t0 we know 0, h by 2 is 0.5 by 2, c0 is 1, k11 already known value, so that is minus 0.4835 by 2, and t0 we know 25, k12 we know 48.35 by 2. So after doing calculation, so that is h is 0.5, so from here we will get 25, so this is 20.025, not 25, 0.025, then after doing the calculation we will get 0.7825, then 48, after doing this calculation we will get 49.175. okay, so you have to erase all this, otherwise it will not visible, it will not give that proper clarification. So now after getting all this, we plug the second equation, and if we do the calculation, so we'll get 36.754. okay, so k121 and k22 we know. Similarly, we can calculate k31, so that is h into f1 t0 plus h by 2 c0 plus k21, so k21 we are getting from here, known, k22 also known, then 0.5 into f1 0 plus 0.5 by 2, 1 plus k21 by 2, so that is minus 0.36754 by 2, plus t0 25, and k22 we know 36.754 by 2. okay, now if we do the calculation, we will get 0.5 into f1 0.25, 0.81623, then 43.777. okay, then we plug this into that function 1. okay, so if you do that, we'll get that the value is minus 0.39542. Similarly, we can calculate k32. so k32, this is function 2, so h is already known, 0.5, t0 0, h by 2 0.5 by 2, c0 is 1, k21 is minus 0.36754 by 2, and then t0 is 25, k22 already know, 36.75 by 2. now in that function 2, we have to plug all this variable, and then if we do the calculation, we will get 39.542. now k44, that formula is h into function 1, t0 plus h, c0 plus k21 plus then t0 plus k22. This is not correct, this is 321 and 322. okay, so now here t0 plus h, so that is 0 plus 0.5, and then 1 minus 0.39542, and then 25 plus this, if we plug all this value, okay, then we'll get 0.5 minus 0.60458 6452, and then this is the function 1, we plug all this value in the function 1, we'll get k41 is minus 0.03692. similarly, we can get k42. okay, so k42's value is h into f2 t0 plus a c0 plus k21 t0 plus k22, so you have to plug all this value. okay, and then ultimately 0.5 f2, so we have to plug in f2 function 2, and then we can calculate that k42 30.692. so we got all these k values. now we can calculate c1 will be c0 plus k11 k21 k2 k31 plus k41 by 6, so 1 plus all these value, k11 this, k221 this minus 0.36754, k31 2 into minus 0.39542, K41 minus 0.30692 by 6. So we'll get that C1 will be that 0.61394, and T1 will be T0 plus K12 plus 2K22 plus 2K32 plus K42 by 6. So we have to plug all this value, and after doing the calculation we will get T1 will be 63.606. Now here I am summarize all these variable. Okay, summarize means we are calculating and different T, what will be the C, and that is capital T value, not capital T. So at t is equal to 0 and t is equal to 0 initial condition, condition t at t is equal to 0, C is equal to 1 and t is equal to 25. At 0.5 after doing the calculation, so that is step size here is 0.5, we'll get C is equal to 0.61394 and t is equal to 63.606. At 1, similar way, if you do the calculation we'll get 0.37639 and t will be 87.361. 1.5 0.23058 101.94, and if for at t is equal to 2 we'll get C is equal to 0.1419119 110.88. For t is equal to 2.5 we'll get 0.086435 and t will be 116.36. At t is equal to 3, so we'll get 0.052907 119.71. So if you do the similar way the calculation, so you'll get this value. Means you can try by yourself for the next iteration. So this is iteration number maybe 0, this is 1 2 3 4 5 6. If you do the calculation by hand if you do the hand calculation, if you do by your own, so you'll get similar value. So means now means here you know how to solve two simultaneous ordinary differential equation by using RK4 method. Okay, even if you have 3 ordinary differential equation, so this variable will increase here. Okay, so if there is a 3 ordinary equation, so another variable will come. Okay, so 1 2 3 fourth number variable will come. If it is a 5 OD, we can solve, so 6 number of variable will come. Okay, so that way you can solve. If you know if you understood how to solve 2 ordinary differential equation, then you can solve any number of simultaneous ordinary differential equation. That's it. So if you have any query, any question, so you can send me mail as well as you can put some comment. Thank you.